protein gates, and, depending on the needs of the cell and the environment the cell is exposed to. Okay. So basically, these are all the major factors that influence, that help us influence the rate of diffusion or movement across the cell membrane. All right. Now, I want to spend a little bit of time talking now about basically just what filtration is and a little bit about simple diffusion and facilitated diffusion. Okay. What filtration is basically when we force water or some kind of a fluid out of basically out of a structure. All right. Now, the example I like to talk about, probably the most common example that you guys that you're going to hear about in the human body when it comes to filtration are with blood vessels called capillaries. Okay, blood vessels called capillaries. All right, you can barely even see that. So now capillaries basically are small blood vessels that have pores in them. Okay, so capillaries are small blood vessels that have pores in them. All right. So let's use this example. Let's say for the sake of this class, please don't actually do this, but let's say you want to learn about filtration and you go to your neighbor's house, you take a screwdriver and you pop holes in their garden hose. Okay, again, please don't do that. All right, so let's say, you hook the hose up to the faucet. All right, hook the hose up, because you don't want to do this to your own hose, you'd rather do it to someone else's sake, right? So you punch holes in the hose. Okay, and then you turn the water on. Okay, what's going to happen as water flows through the hose? It's going to leak out the holes. Exactly, right? So that's really all filtration is. Okay, you're forcing a fluid out of a structure. Okay, and it takes pressure to do this. Okay, now memorize, capillaries. Okay, capillaries are blood vessels. Okay, and blood flows through vessels via blood pressure. Okay, the heart, contracts and relaxes all the time, and whenever the heart squeezes, it forces blood to flow through vessels. Okay, the heart creates a lot of pressure to make blood flow throughout the body. Okay, now the circulatory system is a closed system, meaning there shouldn't be any fluids leaking out except in these small little blood vessels we call capillaries. Okay, you find capillaries embedded inside tissues. You guys know what we use blood for. We circulate blood around the body to, like red blood cells, for example, to deliver oxygen to our tissues. And plus, there's also nutrients like glucose, amino acids, fats, and other substances in our blood that we need to deliver to the cells in our tissues. Okay, and blood is how we do this. All right, so by the time we circulate blood into capillaries, all right, that blood is going to flow by these little holes, these little pores in the capillaries. And the watery component of blood, the plasma of blood, will be pushed out into the tissues. Okay, that's filtration. Okay, and then as we filter that water out of the blood into the tissues, oxygen is going to be forced into the tissues, and nutrients are also going to be forced into the tissues, and then the cells, take in that oxygen and those nutrients. Okay, that's how we basically feed our cells. All right, filtration is also important because there's a lot of capillaries in the kidneys, and a part of this as well is once we reabsorb this water back into the blood and we take in all the carbon dioxide and other wastes, okay, we want to get rid of those. All right, and then those wastes are then circulated to the kidneys and the liver. Well, let's just think about the kidneys for now. Okay, the kidneys are very important organs for eliminating waste. So blood is pumped through the capillaries in the kidneys. We force the fluid out of the capillaries, out of the capillaries in the kidneys, and then all the waste products in the blood. Well, not all, but most of the waste products in the blood flow through the kidneys. The kidneys process this, and you make urine. And then that you eliminate the urine. You pee, and then that's how you get rid of a lot of waste products out of the body. Okay, so that's basically filtration. Okay, forcing a fluid out of a tube or a hose, for the sake of the discussion, and by forcing that water out, you force anything dissolved in the water out with it. Okay, so this is a delivery system for the body. All right, so that's filtration. Okay, and we can affect basically the rates of filtration are primarily affected by blood pressure. Because think about it, I mean, as blood pressure goes up, what's going to happen to the rate of filtration? That'd be like forcing the water through the hose, with more power. Filtration rates are going to go up. Okay, blood pressure gets too low, filtration rates are going to go down. We'll talk more about that in EP2 when we talk about this exchange process in a lot more depth. Okay. Now, diffusion is basically what we've kind of been talking about, the movement of the movement up and down concentration gradients. Okay, I should say down concentration gradients. Okay, and there's two major types of diffusion that I really want you guys to get to know. One of them is simple diffusion. Okay, simple diffusion. All right, basically what simple diffusion is. Okay, remember you've got the phospholipid bilayer. Okay, the plasma membrane. Again, part of the forward drawing here. Okay, so let's say we zoom in on one little part of the plasma membrane. That's what it looks like. All right, and then remember we said that basically anything non-polar, meaning molecules that do not have a charge, can freely pass through the cell membrane. They don't need to move in and out of gates. Okay, so basically what we're talking about here are fats. Okay, and the main type of non-polar molecule that we're really going to talk about and moving in and out of cells are steroid hormones. Okay, steroid hormones are made out of cholesterol. Cholesterol can freely move. These fatty hormones can freely move into and out of cells. Okay, so basically, when we secrete steroid hormones into our bloodstream that need to go to a certain type of cell, all right, normally there are no steroid hormones inside of the cell. Okay, so then once you get these, so let's say these are a few steroid hormones here. All right, once they get to this target cell, all right, even let's say there's only 4 on the outside and there's none on the inside, what directions are going to travel? They travel inward, right? So these steroid hormones are just going to pass right through the cell membrane and go into the cell and then do their job. We'll talk about the job of hormones when we get to the endocrine system. But that's just an example of simple diffusion. Okay, just molecules moving freely across the cell membrane down their concentration gradient. Okay, but most of the time you see something called facilitated diffusion take place. All right, facilitated diffusion. Okay, facilitated diffusion. Facilitated diffusion is a topic we've already been discussing in a good amount of depth. Facilitated diffusion is when we basically use a gate or some kind of we'll call it a gate or a channel, okay, to move molecules across the cell membrane. Okay, and remember, facilitated diffusion is used to move polar molecules or polar atoms across cell membranes. Okay. Because remember, anything that has a charge, whether it's positive or negative, chemically cannot pass through the cell membrane. Okay, so as a result, we get around this by making these gates and these channels. Okay, so basically, once we open the gate, that will facilitate, allow the movement of a specific molecule or atom or electrolyte or whatever it is to move across the cell membrane either into or out of the cell. Okay, but again, this is something that again this is a passive process. Okay, both of these are passive processes. All right, filtration is also a passive process. And again, what do I mean when I say passive? Think about that for a second. When I say passive, there's no energy required. Okay, all we have to do is open a gate or just make a difference in the concentrations, i.e., create a concentration gradient. Okay, remember we've been using sodium as the example. Okay, so there's 150 sodium ions on the outside, 5 sodium ions on the inside. Okay, normally sodium can't pass through the cell membrane because it has a charge. Okay, but if we have a sodium gate and we pop it open, now that facilitates the movement of sodium into the cell in this situation because there's a higher concentration on the outside versus the inside. Okay. Now let's go with potassium. Let's say there was 145 potassium ions on the inside. Okay, and 5 potassium ions on the outside. Now what direction is potassium going to travel? It's going to travel out. Exactly, it's going to travel out because of where's the higher concentration gradient on the inside, right? Remember, this is a passive process, so these ions are just going to move, with, down their concentration gradient. Okay, so that's why we call this facilitated diffusion, because normally these ions or molecules or whatever it is you're thinking about normally cannot move across the cell membrane. So we use these gates to open them to facilitate the movement, into or out of the cell. Okay, and again, that's a passive process.